Welcome to another Tuesday Tech Talk. Today we have Kenneth with us today, Kenny, and he is a Spring developer advocate. And he's going to talk to us about Spring. And I heard a little bit about potentially reactive Spring, maybe?
Probably not.
Probably not?
Not today.
Not today, unfortunately. But without further ado, take it away.
Thank you, Joe. Hey, guys. How's it going? Good? All right. So today I'm going to be talking about cloud-native architectures and microservices, just a general overview, and some Spring things. So it'll be fun. A little bit about myself. I'm Kenny Bastani. I'm a Spring developer advocate at Pivotal. I am from Silicon Valley, but mostly on an airplane somewhere in the world, going to a conference or speaking with Pivotal's customers. It's a great job, but I get to really see a view of the software industry that most people don't get to see. And over the last 2 years, while I've done that, I was writing a book with Josh Long called Cloud Native Java, which is all about building microservices with Spring Boot, Spring Cloud, and Cloud Foundry. So if you're interested in anything I say today, hopefully, you might want to take a look at that book. OK, so I'm going to start out talking about a history of microservices, or why we're doing microservices today, why it's popular. So we started with this. We started with the monolith, right? So most of you are probably familiar with this architecture pattern. Here I have an application server, and inside that application server, I have my deployment, which is my war artifact. And inside that war artifact, I have certain components that different engineers are working on. I have the storefront UI, the accounting service, inventory service, and shipping service. And now the key problem with this is that all of the engineers who are working on this application, who are working on the source code, are going to share this infrastructure, which means that if any one engineer changes one line of code, you have to deploy everything to production or nothing at all to operationalize that change, and that creates a ton of problems. And most of them are just cultural issues. First of all, it's going to slow our velocity getting into production, right? So if we have 1,000 engineers all working on the same code base, and they're all sharing the same infrastructure, if any one of those engineers changes something, you have to deploy everything to production or nothing at all. It also takes way too long to ramp up new engineers, right? So it's not so simple just to add one more engineer to a project to go faster, right? Because they have to worry about stepping on other people's toes. And also, that code base may just be too large for them to ramp up in enough time to actually make a difference. And so it's not so simple. And at some point, that code base really is just too large for any one person to fully comprehend. It may have grown to something like 1 million lines of code. And you may have these people who design the application, these developers, who are like the gurus, who are the most experienced people there. And they may be very productive. And what they're doing instead of writing code is they're just teaching the history of the code base, which is really taxing their time. And they're really not able to do what they love to do, which is to write code. We also have these centralized authorities in the organization. We have our DBAs, we have our operators. And they're really responsible for pushing back, for making sure production stays online. And what ends up happening is that we're hiring all these developers who are tasked with creating change. And we have our operators and our DBAs who are pushing back, right? So it's no wonder why they're at each other's throats, because they have very different objectives. We also have a ton of operational problems with monoliths. First of which is that we're going to have to coordinate a lot more. Now, we're going to have to draw out our release cycles, maybe every quarter, maybe once a year. Who in here is deploying once a day? Just curious. Anyone? Once a week? Once a month? Once a year? Oh, wow. God help us. All right, so I call this taking public transportation to production. Which is that you have to wait until the next bus comes along in order to get a change into a production environment, which means you don't control your own schedule. Now, with microservices, the idea is that we want to go to a model where our developers are able to build their applications and also operate them in production. Because what ends up happening with the monolith is that we have our operators drive the runtime environment of applications, which means that everything on our VMs in an environment is going to be maintained by those operators. And if a developer wants to use a new tool or a new framework and requires upgrading that environment, then our operators are going to have to respond to a ticket. But their primary responsibility is keeping production online. So what they're doing is they're putting out fires all the time, and they really don't have time to go and address these tickets and upgrade these VMs. So our operators are going to take on the full operational responsibility of all of that infrastructure. So all of this change that needs to go into that environment, they're responsible for maintaining it, and that's not a very good model. But more than anything, it's this. You have to deploy everything at once or nothing at all, and that's why this model creates a ton of issues. So then we moved to the SOA, and we got a little bit better at some things, but got pretty bad at other things. And so at the top here, I have my services team, and they're managing 3 separate deployments instead of 1. I have the accounting service, inventory service, and the shipping service. Now, what we got better at is that we realized we shouldn't share the infrastructure for certain code bases. And so we've split out this code base into 3 separate different deployments, and I can deploy those deployments independently of one another, which means that if I make a change to one, I can deploy that, and I don't have to worry about the others. But what happened over time is that we didn't realize that sharing libraries was going to also cause an issue. That is, if I make a change to the customer record there at the bottom, or the accounts record, then I just deploy the accounting service. But what happens when I deploy the address, or I make a change to the address record here, then I have to deploy all 3 of these applications together. And then if there's a defect, I have to roll all 3 back at the same time. And so this becomes a mess in practice. And so now we've arrived at microservices. And the simple idea of microservices are, we're not going to share anything anymore. We're going to have our developers build and run their applications in production. And they're going to be a small team, anywhere from 8 to maybe 15 developers, with a relatively small code base that's going to tackle one small part of the domain. So they're going to do one thing well. And the idea here is that our developers are going to have everything that they need to really self-service. That is, if they want to use a certain database like Neo4j, which is a graph database instead of an RDBMS, then they can go ahead and use something like Cloud Foundry to provision that for their application. But we got a lot worse at some things, which is that there's a lot more yellow here. And so if you want to think about that database, that single database in the back end, as a developer, I really didn't have to worry about transactions too much, right? If something went wrong in a transaction, a database transaction, it would just roll back to the previous state. But instead here, now I have all these different databases that I have to worry about. And what about foreign key relationships from one database to another, right? Think about that. So here in this example, I have a user service, movie service, rating, recommendation, and analysis. Now these 5 separate microservices have 5 different teams, all independently deploying features to production, and they're managing their own database. And so the idea here is that when we split up this domain into many separate parts, we're going to have these relationships going back and forth between different services. And so that creates an issue with consistency, which is that now I have to worry about distributed transactions, I have to worry about distributed systems, and I have to worry about eventual consistency. And so this is actually one of the hardest problems in computer science. And so we're tackling a very hard problem now, which is to make sure that we have all of our data consistent in a microservice architecture. All right, so I'm going to walk you guys through an online store example here, which I built for the Cloud Native Java book. And it's called Cloud Native Outfitters, which is an online store that sells just 4 T-shirts about the cloud and a hoodie. And so we're just going to take a look at this. I'll have you guys guess how many microservices. This is static content we're looking at here. This is AngularJS, so it's just HTML, CSS, and JavaScript. So I'll go to one of these shirts. And we can see the product details from the catalog here. And that might be coming from something like a catalog service. I can see here that I can add some of these to the cart. I also see my related items down at the bottom. Before I can do that, I need to sign in. So I'll go to the top right here and log in. And notice that I'm redirected to a different URL. So we have at least 2 applications here. This is an OAuth 2 gateway. And I'll go ahead and sign in. And that should redirect me back to my application and give me a nice little error, which I know about. Just going to turn off security. It worked for Equifax, so go ahead and do that. All right, and then at the top right, we should see state change if it didn't blow up. There we go. So at the top right here, I see that I'm now signed in as John Doe, and I have a couple other options. I have my orders, my account settings, and my shopping cart. So now I can go ahead and add a few of these to my shopping cart. So I'm going to buy this one for a friend. 3 friends. And we see that the product was added to the cart. So now I can go to my shopping cart here. I see those 3 items. And I'm going to go ahead and check out. That's going to create an order and create a shipment. And so with success, we see that the order status is pending. We see the ordered items, and then finally the shipping address, which is coming from my account settings. Now, as a front-end developer, think about how you're going to work with maybe 500 microservices in the back end. In the case of Netflix, they have over 500 different microservices. And so we want to make sure that our front-end developers don't have to worry about all that complexity, right? And so we have a way to do that, and it's called an API gateway or an edge service. So how many microservices do you think are powering this application? More than 2. Just throw out a number. 10. Nailed it. You saw this presentation before. Okay. There's 10. Yeah. And this is what it looks like. So here I have my 10 microservices. 1, 2, 3, 4, 5. I just want to make sure. OK, so at the top right, I have my online store web. That's the application I interacted with, right? That's the application that's going to host my static content. My front-end development team is going to be working on that online store web. And that's fine that if I split this off into different modules. Maybe I have a small team who's working on some features. I have a small team who's working on some features. And maybe that's somewhat of a monolith. But for the front-end workflow, things kind of change. The rules are kind of blurry. But what does matter is that whenever there's state or there's a database attached, and there's business logic, then you want to have a small team of developers, maybe with one product manager who's an expertise in that domain, who's going to translate the requirements from the business into features, or stories, rather. So the API gateway is here in red. That's the edge service. And that's how these front-end developers are going to be able to integrate to use these back-end APIs without having to worry about where they're going to, right? So what they'll see is just an API contract for the entire domain. They won't have to worry about going to individual services. They'll just go to /catalog or /account or inventory, and they'll use that API, right? Just like a monolithic application. Now, here in the middle, that's what we call the backing services or cloud platform services. Whatever you want to call them, they're reusable microservices. That is, they're going to help me solve non-functional requirements that allow me to integrate my microservices together and manage this distributed system. So the discovery service here in blue is going to allow me to find other services in my environment without having to worry about configuration or host names. The configuration server here in yellow, that's going to manage all of my configurations centrally so that I can make a change in a production environment to a config and push that notification out to any one of these services, and they'll reload without having to restart or having me rebuild that application and deploy it to production. And then we saw this application here. That's the user service, which is my OAuth 2 gateway. And I'm going to reuse that for all services for authentication. And we can see the user database here. That's where I'm going to store my user records with credentials. Now, the main problem with this is that with a microservice architecture, you have all these foreign key relationships, right? So from this user database here, I might have a user ID, which relates to the account service by an account record. And by the catalog service, I might be tracking certain things in the inventory, and so I have a relationship there. And so if any one of these things changes in the foreign key relationships, then I have an inconsistency, and I have to worry about that as a development team. All right, so that's the 10 microservices. Now I want to talk about migration, because this is just a greenfield application. And so migration strategies. There's 2 popular migration strategies for going from a monolith to a microservice. The first one is called splitting the monolith. And this was discussed by Sam Newman in his book, Building Microservices. And he said, what you can do is look at your monolithic application and look at the modules inside that application, and you can rip them out and create them as separate services. Now, this looks really good on paper, but what ends up happening in practice is that it's not so simple, because you have to look at the entire architecture. And the entire architecture may include more things than just this. You might have a data warehouse in the back end that's running ETLs back and forth between third-party systems and this database. And so we have to worry about that as well. But just to walk through this process, how it might work is I'll start by looking at my back-end schema here. And I'll decide on which one of these tables is best suited to be ripped out and migrated to a new database. And then I'll refactor out any functionality related to that database table and put it in a new service. But the first thing I can do, the easiest thing that I can do, is to rip out stateless functionality. So let's say that this used to be just one application, and the front end was combined with the back end. So here in blue, I have my online banking application, and that's just front-end content. So I can extract that out, create it as a new service, and that's really easy. But let's say that now I want to split that back-end service. So I've chosen to use the user module and refactor that out as a new microservice. And so I've gone ahead and I've migrated out the user table here and put that into a new database called the user DB. And here I have my new user microservice, which is now going to have a small team of developers, maybe forked from the customer service, and they'll be building and they'll be operating that application in production. Now the key problem here, right, is that if I want to do this, then I have to have a maintenance window, which is I have to worry about shutting the system down and migrating all of those user records to the new database. But even more than that, I have to rip apart those foreign key relationships from that customer DB, and that's going to cause me a ton of grief. So in practice, this actually takes a lot longer than most companies think. But there is a solution. It's not all a bummer. What is pretty popular is this thing called a Strangler Pattern. Who's heard of it? Great, a few people. So the Strangler Pattern was introduced by Martin Fowler. And Martin Fowler, back in 2001 or 2002, went to Australia, and he saw this thing, which is called a Strangler Vine. And the Strangler Vine, what it does is it seeds itself in the upper branches of a fig tree, and it works its way down to the root system, strangling the tree by stealing all of its resources. And what's left is just this stump in the middle, but you have this vine that's grown around it. And so Martin Fowler saw that, and he said, well, this sounds like a great way to strangle my legacy. And so he said this. He said, what you can do is you can gradually create a new system around the edges of the old, letting it grow slowly over several years until the old system is strangled. And so the question is, how do we apply this strategy to microservices? And so I put together an example of this and how some companies are doing this today. The idea is that you're going to run your legacy system side by side with all your new microservices. And so what you'll do is you're going to develop all your new features now in the microservices rather than in your legacy system. But you're going to need to strangle out that data from a large shared database. And so in this example, I have a web services architecture, and I have multiple services that are all sharing that same database. Here I have an example of a SOA, which has an ESB on top of these services, and that gives me something called an indirection layer. Which means that I don't have to go back and touch any of these services to implement this pattern. So if I did spend that effort and go and refactor or change these services, I would need to change the way that they do routing. So in the web services architecture here, instead of going point to point, I'll go through this thing called a legacy edge adapter. And this legacy edge is responsible for implementing a caching pattern, which is that whenever a record is requested from a microservice, that microservice will reach into that backend for that record and then migrate it to its own database. And so then all of the backend services here and the legacy services will start to go to that new microservice instead of going to the database. And so what that gives you over time is more options. Now, if you were to go to the business today and say, 100% of my users are going to be affected by going to microservices, then they're just going to probably say no. But over time, as there's less dependence on that bottom layer, maybe 1% of the users are affected over 10 years, then it's much easier to reason about doing a big migration. And so here's a modded architecture from earlier. We saw those 10 microservices. So up at the very top, we have our new UI. So I have the profile web application here, and I'll have my front-end team all working on that service. And then I have my platform services here, or backing services with that API gateway. And then I have my microservices. So all of my new features are going to be developed in this layer here. And we're going to have an architecture that's able to extract out and migrate that data from the legacy system and put it into this microservice database. And so we're going to use a pattern called the facade pattern. And that facade pattern will have this new microservice sit on top of this legacy service here, which is the customer service, which is using called legacy format, SOAP XML. And that legacy edge adapter is going to translate between modern formats like JSON or Google Protocol buffers and SOAP XML. So whenever a legacy service requests something from the customer service, they'll get it in SOAP XML. And whenever a microservice requests it, it'll get it in JSON. And so that makes it very easy. And so that's the basic idea of this pattern. And so this works really well in practice because it gives you all the benefits of microservices, which is really velocity, the ability to go faster. I have like 45 minutes, so I'm like speeding through this stuff, so I apologize. I wrote a book on it, so if you want to buy the book. Okay, so now let's do some demos. I know most of you here are probably familiar with Spring Boot, but I'm going to do a really quick demo here. Actually, I'll explain it first. So what is Spring Boot? I like this tweet by Phil Webb, who's one of the founders of the Spring Boot project. And what he said was Spring Boot really is auto configuration, which is that it's an opinionated default for the Spring framework, which allows you to just pick the ingredients that you want instead of having to worry about composing them yourselves. So the eggs here might be Spring Security. The flower might be Spring MVC. And before Spring Boot, what you had to do is manually configure and wire up these components together every time you wanted to create a new application. But now with Spring Boot, what you can do is just choose those ingredients, and you're going to get an opinionated default that you can override. And how we do that is we use a site called Spring Initializer. Now, Spring Initializer is kind of like the kitchen or the restaurant that you go into and you look at a menu, choose your ingredients, or choose what you want to eat on the menu, and you get a finished product. So here I'm going to create a basic microservice, which is called the user service, and I'm going to choose some dependencies. First of which, I'm going to choose web. That's going to give me my application server baked into the artifact that I create. So instead of having a war deployment onto a central application server, I'm going to bundle together my application server with my application. So I'll choose web. Then I'm going to need a database, and I'm going to need an ORM technology. So I'm going to choose Spring Data JPA. And then I'll need a database. So I'm going to choose H2 here, which is an in-memory embedded database, and this allows me to do things like unit testing in memory. So if I want to run integration tests against my database, I don't have to go to an integration environment. I can just run those locally. So I'll choose H2. Then I'll choose REST repositories. That's going to give me a REST API on top of all of those POJOs I've created, like a user object, and I don't have to worry about standing up a REST API for those objects. And then finally, I'm going to choose something called Actuator. And Actuator is a project that's going to give me a set of operational endpoints out of the box, things like an info endpoint or a health endpoint. So I'll choose that. And then I'll go ahead and generate the project. And that gives me my source code here at the user service. And what I'm going to do is just start that up. That'll start on port 8080. Okay, so it started up, and now I'll go to my browser. And at port 8080, we get a response in JSON. And what we're looking at here is called hypermedia, which is a format that's going to link other API calls to the response we get back. So we know how these things are connected. Now, this profile one doesn't do much, but if I go to /actuator, I'm going to get many more options. So we added Actuator as a starter project, which is going to give me these set of links that allow me to really inspect and monitor my application. The first of which is at /health. And very simply, this just tells us the status of the application. Now, this looks very simple, but as you add more projects to the ecosystem, rather more Spring projects to this app, let's say Spring Cloud with microservices, you might be able to see your dependencies as well. So you'll be able to see which one of your microservice dependencies is up and running, as well as if you add a database, you'll be able to see the status of your database. So you get a lot more here. Now, if I want to look at anything else, I need to disable security from those links. Now, if I go to start.spring.io, which is a Spring Boot application, and I go to /env, which is another Actuator endpoint, I'll be able to see everything about the environment that this application is running in. And in this case, it's running in Cloud Foundry. And so I see information like the system properties, as well as the environment variables, where that application is running. Now, if I go back to my Spring Boot app here and I try that, and I get an error page because it's locked down. And I think that's probably for the best. But I'm not so sure. So the Spring engineers, I think, are just waiting to be hacked. So if you look at some of these things, you might see a key or some credentials to a database. But what they've done to protect that is that they look at the name of that key, and they'll just obscure whatever that value is. And so here we don't have anything that would allow anyone to hack anything, but probably a good idea to lock it down in production. Now down at the bottom, we have something that's really important, which is our configuration. And so when we're talking about 12-factor applications or cloud-native apps, we want to store the configuration in the environment instead of baking it into our build. And so here I can see exactly where that configuration is coming from. And it's coming from the class path, which means that it's baked into the app. So this is not really a cloud-native app. But instead here, we might want to pull this from a configuration server, which will be delivered to that app in its environment, and it'll use those configs to start up. So another endpoint we have is metrics. And metrics is going to give me a snapshot of everything that's going on in that application's environment. So I see things like the system memory that's available, the amount of memory being used by the application. I see information about the JVM, garbage collection. And if I go all the way down here, we also have our metrics for counters and gauges. Now what's really cool about this endpoint is that I can actually report all of these gauges and counters to something called Prometheus, which is a time series database. And that can plug right into a tool called Grafana. And Grafana is a visualization dashboard which will actually give me time series and charts to monitor my applications in an environment. And you really get that out of the box without having to worry about too much setup work, which is great. All right, so moving right along. So this is really an abstraction of, I have to change this title, but I'm just going to talk about generally what cloud platforms do. So for cloud-native applications and microservices, we're going to ship them using a cloud platform like Cloud Foundry. And I think probably most of you know how this works today, so this is just a review. Who's heard of Docker? Anyone? Yeah, most people, right? OK, so here I have a virtual machine. And what containers are is really a feature of the Linux operating system called cgroups and namespaces. Now, Docker popularized this functionality because what it does is it'll allow you to run a file system on top of the Linux kernel that's isolated from other file systems. Which means that I can run two different distributions of Linux on the same virtual machine, and they won't see each other. And that means that instead of having to worry about just one VM per application server, I can have different runtime environments bin packed into one VM. And so here I have one virtual machine with 3 separate containers, one for Python, maybe one for Ruby, and one for the JVM. And so that's the basic idea. Now, when you look at a cloud platform, what it's going to do is it'll pull together these different VMs. Here I have 4 different virtual machines, and I have all of these containers that the cloud platform is scheduling in parallel. And so here's my capacity buffer here, which is in white. And what happens is I can go ahead and I can push my application, and the cloud platform will kind of play Tetris with scheduling that on one of these VMs. But what it'll do also is give me the ability to auto-scale my application. And so the cloud platform will monitor over time the usage of an application in one of these containers. And if it's running low on availability, which is that maybe it's peak load and it's at 70%, the cloud platform can schedule another container and increase the availability automatically. And then over time, once that peak load goes down, it can deprovision that container and release that additional availability. And so the problem here is that when you run distributed applications or microservices and in a dynamic environment like this, you have to worry about where your dependencies are going to be. And so as I scale up, I want to know as a dependency where that application is now located. And so what I can use is something called service discovery, which is going to tell me where my application dependencies are located in real time. And that's a subject of a tool called Spring Cloud. So on top of Spring Boot, we have Spring Cloud, which is going to allow us to easily manage our distributed systems. And going back to what Phil Webb said about Spring Boot, he also tweeted later that day a delicious picture of some cupcakes. And he said, well, this is really what Spring Cloud looks like. It's really all of these different cupcakes with their different flavor and icing on top. And we really have to worry about how these things glue together, right? Because we still are building one system. It's just composed of many separate deployments. Now, what Spring Cloud really is just a set of integrations from popular open source projects, like Netflix OSS, which has over 40 open source projects. And back in 2008, Netflix decided they wanted to go cloud native. That is, that they partnered with AWS, and they were going to build their new video streaming services on top of Amazon. And as a part of that decision was because their DVD shipping service, their website, went down in the holiday season. It was like 3 days that they went down because of a vertically scaled relational database had a database corruption. And so they created an open source project called Netflix OSS, which really became Spring Cloud, or certain components within that portfolio, things like a service discovery, or things like an API gateway. So now I'm going to do a few quick demos of Spring Cloud. I'll start with service discovery, which allows applications to find each other in an environment. I'll show you what an API gateway looks like. So earlier we looked at that edge service, and we saw how front-end developers are going to add features or work against one monolithic API with many back-end services. And then I'll show you how to use a configuration server. Circuit breakers I won't show you, but I'll just talk about it now. Circuit breakers give us some resiliency. When you have a distributed system, what could happen is that you might have a critical dependency. And if that thing goes down, everything goes down. So circuit breakers builds in isolation between these services. And they'll measure the velocity of errors downstream. And if there's too many errors, what it'll do is it'll just go to some backup default functionality, which will restore service, degraded service to that part of the system. And then I'll show you an example of distributed tracing, which is really a map of how all these dependencies are connected. All right, so the first demo here is going to be service discovery. And this allows applications to find each other in an environment. It's an essential component when you have a cloud platform. But each application is going to handle its own routing instead of handling routing from the server side. And what changes for the developer is that instead of using a URL, they'll use the name of the service that they want to communicate with. And how this is done is it uses a service registry, which is a lot like a phone book. I'm going to subscribe to that phone book, provide my information, and I'll get the information of all of my dependencies back. So as an example here, I have 4 separate applications. And let's say that the recommendation service and movie service are dependencies. So when the recommendation service starts up here, it's going to contact the configuration server. It's going to fetch its own config, which is going to tell it where that discovery service is located. It'll check in there, provide its information, and in return, it'll get back a service registry for where the movie service is located. And here's what that service registry looks like. So we'll have multiple applications, and per application, we'll have multiple instances. And what this allows us to do is something called client-side load balancing. Because I know where all my dependencies are located, I get the benefit of load balancing between the instances that are available. So in this demo, what I'm going to show you is the user client here has a dependency on the user service, but we want to scale up that user service to multiple instances. And so what I can do from the client side is just load balance between these two. I don't have to worry about server-side load balancer. So the first thing that I'm going to need is a discovery service. So at start.spring.io, refresh here. I'm going to go ahead and I will choose Eureka server from the ingredients. And that's going to give me that full working discovery service. And that one's from Netflix. But we have others. For this example, I'll show you Eureka. I'll name it Discovery Service. And I'll go to that project. Oops, that's not right. I'll open this up in the IDE. And in the source code here, to enable this Spring Boot application as Eureka, all I'll do is I'll go to the application class here. And in the application class, I can go ahead and add an annotation here on top, which is called Enable Eureka Server. And that's all I need to do. Now, when I start this application up, it will assume the role of a Eureka discovery service. But I also need to worry about overriding some configurations. And so by default, all Spring Boot applications will start up on port 8080. But instead, what I'm going to do here is change this to 8761, because by default, all Spring Boot applications that are subscribers to Eureka will look for it on 8761. And then really the only rule of Discovery Service Club is that all applications need to have a unique name. That is, if we have duplicates, let's say 2 different services with the same exact name, what will end up happening is that you'll start to load balance between 2 separate applications, which we know is probably not a good idea. So I'll name this Discovery Service. And that's it. So I'll start this up. Great. So it started up. And I'll go ahead and go to my browser. And we see Spring Eureka. Now, this is a very simple dashboard. Now, if you look at some of the names here, you'll see things like AMI. Who knows what an AMI is? What's an AMI? There you go. Yeah. And, of course, we know that there are many different clouds, right? Not just Amazon. And so the reason why we have words here like AMI is because back in 2008, Netflix partnered with Amazon, and all their things were built against Amazon. But Eureka is used on multiple clouds. It's cloud agnostic. So if I refresh here, you'll see that Discovery Service has registered itself. But you'll see here, no AMI, right? And I'm pretty sure I'm not in availability zone, which again, is exclusive to Amazon. But I can run this on GCP. I can run this anywhere I want. I can run it on my laptop. But the idea here is it's going to tell me where this application is running. And this isn't very useful because we're already at the Discovery Service. But what I'm going to do here is I'm going to create 2 subscribers, the user service and the user client, which I've already created. And we'll start by looking at the user service. So going to the application class here, what I need to do to enable this as a subscriber is to add the annotation enable discovery client. And here in the controller, I'm going to override that JSON hypermedia response by adding a root endpoint here, this request mapping, to return where this application is running, rather just the port. And that's going to allow me to see from the client side who I'm communicating with, right? So if I'm going to load balance between these things, going back to this diagram, I'll be able to see which port they're running on. Now again, I need to give it a unique name, and I'll name it the user service, and that's how the user client is going to know how to communicate with it. And I'll go ahead and start it up. Oh, port 0 means start up on a random port. But I'm going to override that here. Good question. Because I want to make it easier to read. So I'm going to override that port from the command line, and I'm going to set it to 1111. And then I will start up my second instance and start that on a different port. And you can see here in the background, Eureka's log output is showing that these services are successfully registering. Now, if I go back to the user interface here and I refresh, you'll see that the user service has registered and that there are 2 services now available for the user service. And so I can go to one of these and zoom in here. If I go to the root endpoint, I will get back the response for the port that it's running on. Not so useful if you already know where you're going. But from the client side, you'll be able to see exactly where you're going. So the next thing I need is my client. And it's a very simple application, the same as before. There's some other things going on here, like Zool Proxy, which I will talk to you in a little bit. I'm going to use this demo over and over again. But again, we need to enable this as a subscriber, so enable discovery clients. And then I'm going to configure a REST template, which will be my REST client, which will allow me to contact that user service. But to enable this to use the service registry, I have to add another annotation here called load balanced. Now, if I remove this, then it won't be able to actually look at that service registry. It's going to use just DNS to look up its dependencies. And then in the controller, the same as before, I'm going to create a reverse proxy. That is, I'm just going to return back the result that I get from that downstream service. And so I will use the REST template here to do a get for entity, which will make a GET request to this URL. And of course, we know that this isn't a valid URL. We're going to use the service registry to swap out the name user-service with an IP address and just return back the response. So I'll go ahead and start that up. And we'll see Eureka has registered it. Now, before I go to it, I want to show you the service registry. So if I go to /Eureka/apps, I get the service registry, which is that phone book. And we'll see all the information of all the dependencies and subscribers that are registered with Eureka. So here I have the user client, and we see things like the instance ID, the host name, the app name, as well as the IP address, everything that I need to know about this dependency, as well as its health status. So if I scroll down here, you'll see those actuator endpoints that we looked at earlier, the info endpoint and the health endpoint. Now, in this schema, I have multiple instances per application. So for the user service, we'll see here I have 2 instances available running on their separate ports. And so that's how the magic happens. Now, if I go to the user client and I go to that root endpoint, we'll see that it gets a response back from one of those user service dependencies. Now, if I refresh this page over and over again, we'll see that it load balances between those separate services. So it's very useful. Now, why this makes sense is if you look at the online store here with its 10 microservices, let's say that they're all using service discovery, and let's say it's using a cloud platform, which is going to scale up these instances automatically if they need more availability. And so what ends up happening is that all the dependencies will get an update from the discovery service saying, hey, you have a new instance available, and it'll start requesting from that service in addition to the other ones. And so we can automate how we're able to adjust the availability based off the amount of load. We don't have to worry about manual configuration. Okay, so the next demo I'm going to do is the configuration server, and this is how I manage all my configurations centrally. So as an example, let's flash forward here. Here I have my 4 separate services from earlier. I have my recommendation service, my movie service, config service, and my discovery service. Now the configuration service is really going to map to a Git URI. That is, that Git URI will act as the file system for all the configurations for each one of the microservices. So here I have my staging environment, and that's using a different URI than my production environment. So I have all the same artifacts that I'm deploying, and how they know that they're in a different environment is that they will use a different URI to find their configurations. And so we're going to use the same demo here, and if I go to /message, and this is on the user client, I get back a response that says, I don't know what I am. And that's because what I didn't show you was in that controller, I have another request mapping, which is bound to a property called message. And so if I look at that field up here, I'm injecting in that configuration value from my configuration properties by key message, and I'm falling back onto this value if I can't find it. And that's why I'm getting that response. And let's say that I go to my configuration here, in application properties, and I change this to message whatever. Then I will see a response that reflects the value of that key. But this application is configured to look for a configuration server. And so in the POM XML, one of the ingredients that I added was Spring Cloud Starter config. And so by default, it's going to look to localhost 8888 to try and find that configuration server. And since it's already running, what I'm going to do is just start up that configuration server and tell it to refresh its config and get its value. And so I already have that here. And while that loads, I will go to the source code. So to create a configuration server, I'll add the annotation, enable config server. And if I go to my application properties, we'll see that I've changed the port to 8888. And I am going to use this GitHub URI, which has 3 files, userservice.yaml, userclient.yaml, and an application YAML. Now I've mapped that to my local file system. And so here we'll see that the application properties for user client, I've commented out the message property. For application YAML, it says I'm an application. And for the user service, it says I'm the user service. Now that the configuration server is running, I can go to the user client and tell it to refresh its configuration, which means that it will attempt now to go to that config server to get all of its configuration properties. And so it was able to do so, and we can see that the message value here was updated. So now if I go back to the user client, without rebuilding this project, we'll see a different response. It says, I'm an application. Now the reason that is because for its individual configuration, I commented out message. Right, so going back here to Adam, we see that I commented out. But it will fall back to the application YAML to get that value. And so you can override these configurations using different files and profiles. And this allows me to target all of my services in an environment. So if I want to change the way all applications log, I can put that in my application YAML. And if I want to override it, I can put that into my local configuration. So let's fix this. I'm going to go ahead and uncomment it. And then I'm going to send a notification again. Oh, I have to commit it. Very important step. Check in your code. All right, so here I have my user client YAML. I'm going to do git add, git commit, git push. So we see that it was updated, and now I'll post. And it was able to update that value. And now if I refresh, we'll see that it says I'm the user client. Now this is a trivial example, but if you want to think about the power of the configuration server, everything in Spring Boot is configuration. How all of these components are wired up is using a default opinion, a configuration that I can override. And so if I want to modify the behavior of any one of these applications, I can modify a configuration file, push that to GitHub, or Git rather, and I can send that notification out to the service that's affected. And I can do this automatically, which is very powerful. Now I have like 2 minutes left, so I'm going to stop here. Oh, I got to show you the API gateway. Got to show you the API gateway. All right, so the API gateway here in red, that's going to allow my front-end developers to communicate with all the back-end services using a reverse proxy. Now earlier what we did is we went one-to-one. We went from one service to another using a REST template, and we saw the load balancing. I don't even have to do that. If I go back to the browser here for the user client, because I added that annotation earlier, enables will proxy, if I go to /routes, you can see here that I have relative routes mapped onto my own application here, which will go to any one of the services that are registered with Eureka, including user-service. So now if I go to user-service, I'm going to get that same result. I refresh over and over again. It still load balances. But I also can go relative to that path. So if I wanted to go to, let's say, Actuator, which is at /env, I can also see that it load balances between those different environment endpoints. So very useful. I don't have to worry about doing all of that manual effort to be able to reverse proxy to other services. All right, so that was quick. But I'm going to go ahead and close it down here. Thank you guys very much, and I will open it for questions. Any questions? All right. Well, thank you guys. I will be up here if you have any questions. If you can think of anything, also buy my book. Thanks.